All right, thank you, everyone. Awesome. Okay, hi everyone. This is Micheal from Brevis, and I'm here going to talk about Brevis, a smart off-chain verifiable computing platform, and how that is relevant to DeFi AI in the future. So first, just want to kind of introduce why do we need off-chain verifiable computing in the first place, right? So like if you look at many of the DEXs today, just as a very simple example, every single DEX in the world doesn't even have this kind of a very simple functionality every centralized exchange have, which is a trader volume-based fee discount program. Like if you trade a lot this month, you'll get a trading fee discount next month. Well, the reason you don't have this kind of a no-brainer feature is that because running these kind of a computation, even just accessing data to compute what is a user's historical trading volume on blockchain directly, turns out to be extremely expensive. Even on the lowest cost layer 2, it costs you this much dollar and this many time to actually do this kind of a simple computation. So how do we solve that? Well, we are faced with this challenge where we have a blockchain as a world computer, but it's a very, very, very slow computer that can never run faster than a single server. So the solution is this: off-chain verifiable computing. So instead of relying everything on the blockchain execution engine itself, we can actually offload very data-heavy and complex computation to an off-chain world, and we can do the computation there, then lower the cost of the computation. But the immediate question is that, okay, what happens if the computation done off-chain is actually wrong, is manipulated by any malicious party? Well, this is where zk comes into play, where you can actually generate a zk proof of the computation result itself that can be easily verified by any party. And in this particular case, you can now take the zk proof of the computation, bring it back to the blockchain, and stuff it in a smart contract. And the smart contract can easily verify the zk proof with very low cost, much, much lower than the computation itself. Now, with this kind of off-chain and then on-chain cycle, what we have is that we can basically tap into infinite amount of computation power and at the same level of security of blockchain itself, because now we have like zk proof to prove the result of the computation. So, this is what exactly what we built in the beginning. So we at Brevis, we first solved the data problem. So we built something called a zk data coprocessor that allows smart contract to access historical on-chain data and run arbitrary computation on top of them. And this can already you power a lot of amazing application use cases that you can see. To build this kind of application, you just need to specify what kind of data you want to access, what kind of computation you want to run, and directly verify it in the smart contract. We have, in fact, partnered with all of these amazing DeFi projects to power their next generation intelligent DeFi features. For example, we are powering and launching the next generation PancakeSwap Infinity protocol with PancakeSwap. There will be a lot of pools enabled with Brevis-powered intelligent hooks that allows you to individualize and customize user experience based on the historical behavior of user interaction on the DEXs. We also partner with Euromoney, which is a rising star in the stable token system, and we're distributing $300 million of incentive per year by allowing users themselves to generate a zk proof of their interaction. So, we have the data problem solved. Like if you want to access anything that is on-chain and run any computation, you can do it with zk coprocessor. But zk coprocessor itself has some limitations. So our first generation SDK only allows you to do relatively simple computation that is based on kind of a certain predefined SDKs. So let's say if you want to run an AI agent that is ingesting on-chain data, and then generating a decision for user to manage the user's fund. In this particular case, you can say, okay, a user is trying to chase a yield, and your DeFi AI agent is managing and looking at all the user data, all the market data, and then generate a proof. So and then generate this decision for user to actually kind of change the allocation or yield allocation of the user balances. How do you do that? Well, right now, what you do is you connect with a large language model, or in general, like a large model, and you get some result. But the problem is that if you rely on a decentralized network of model hosts, how can you tell whether this model is actually an intelligent model, or it is like run by some shitty server that gives you like just a crappy result? Because in the end of the day, you're facing a black box. You have no way to understand what is happening and what kind of a computation is done in the black box. So, this is where zkML or verifiable inference comes into play, where you can actually generate a verifiable zk inference result to show that a certain inference result actually comes from a pre-committed model. What I mean by pre-committed model is that you can basically say, okay, I can testify, or I can attest to the fact that when I input this data to a certain high quality model that has passed previous benchmark tests, this is going to be the result of the output. And this is indeed coming from this pre-tested, pre-qualified model itself, not just some random model hosted by someone else. So, to do this, to enable this, we actually need a more generalized ZK framework, something called a zkVM, that can actually run arbitrary computing on top. And to build a good zkVM, you really need to build it with 3 characters. One is that it has to be future-proof, because zk itself is progressing really rapidly. And second is that it has to be developer-friendly. Ideally, you can just migrate your DeFi-AI agent framework seamlessly without actually knowing anything about zk. And third is that it has to be performant, because zk does add overhead at the same time of adding verifiability. So, this is the 3 things you need. Well, we built something called a Brevis Pico VM that does exactly that basically solves all of these 3 challenges. We provide the way we solve this challenge is by introducing a highly modular architecture in the zkVM design. Let me explain that. First of all, Brevis is extremely performant. Right now is the world's fastest zkVM on CPU, and we're releasing our GPU accelerator next month to be actually the fastest in the world in GPU accelerated version as well. And when I talk about modular, what I mean is that every zkVM today is built using this glue and coprocessor architecture, where you have a glue as the general RISC-V or any kind of ISA set, and you have some coprocessors specialized to accelerate certain specific operations. Most of the existing zkVMs only focuses on accelerating very specific low-level operations called precompiles. But for Brevis, we introduced something new called app-level coprocessor that allows you to offload a large chunk of application business logic to not only just the specialized circuits, but the specialized system that can run faster, more efficient, and more secure. So, by using, I think this slide has Micheal, but by using this kind of zk or app-level coprocessor, you can achieve an amazing result for use cases such as DeFi-AI agent. If you want to run AI agent, we have a zkML coprocessor that allows you to generate a verifiable inference result about 50 times faster than just using a general vanilla zkVM. So, finally, just some lower level detail that is, if you want to, we built this to be extremely modular in the sense that you can actually switch different proving backend with just one line of code change. That basically means that whatever new research, new innovation came out from the zk, research space, you can just directly adopt that without actually changing your code or architecture. And we also have a very flexible proving pipeline. What this means is that in many of the verifiable AI use cases, you are not actually trying to prove things to the blockchain. You're trying to prove things to some human or some off-chain services. In this case, you don't actually need to run every single step in this particular pipeline. You can just mix match them and do whatever you want. For example, you can drop the embedding step to save a lot of time to kind of actually generate a very, very small proof. And you can, in fact, mix and match different chips to build a more optimized and more efficient zkVM specialized for specialized for verifiable inference tasks as well. So yeah, we have been working together with a lot of the well-known names in the DeFi space, initially on the data access part, but we're expanding to more computation use cases as well. So yeah, if you're interested in kind of building something with us, I'm going to be here. Feel free to talk to us. Thank you.